everyone! For the discussion this week, I had number 21, which is use factoring to find zeros of polynomial functions and determine end behavior. End behavior of a function describes the behavior of the graph at the ends of the x-axis. So let's go over some vocabulary before we start. And the notation that we use in the vocabulary that we use is as x approaches positive infinity, this is how we say the right side of the graph. And then for the left side of the graph, we say as x approaches negative infinity. And then just to cover a little bit more, we're going to describe the zeros. The zeros of a polynomial tell where the graph will meet or cross the x-axis. These are all very important things to know because by determining the trend of a graph as well as the zeros, we can visualize it before actually graphing it. So before factoring, we can look at the equation to find and visualize the end behavior. Most commonly, the first term in a polynomial function or the leading term determines end behavior. So our leading term in this equation, f of x equals 4x squared plus 3x, is 4x squared. So the first step is to determine if the coefficient is even or odd. And here it is even. It's not negative because this would cause the graph to trend downwards. And so step 2 is the leading term squared, cubed, or etc. So if you know your graphs at all, you know that when we have a quadratic function, the leading term is going to be squared. And so we can visualize that the graph is going to be a parabola and look like this. So already I can get an idea of what the graph is going to look like. So we know that it is squared. And so next, we're going to write out the proper notation to describe this end behavior. And right here, I've already written down the proper notation that most textbooks use. And so we're going to say, as x approaches negative infinity, this is saying the domain, so the left-hand side of the graph. So as x approaches negative infinity, it's asking where's the range going to go, or f of x. So because we've already visualized this graph, we looked at the leading term here. And since it's positive and it's squared, so it's quadratic, it's going to be a parabola, we know that it's going to trend upwards. So we're going to say, as x approaches negative infinity, f of x approaches positive infinity. And then we go to the next part, and it says, as x approaches positive infinity, so the right-hand side of the graph, f of x approaches also positive infinity. There you go. There's your end behavior. And so now that we can determine end behavior, let's factor a polynomial to find the zeros. And the zeros of a function are going to tell us, once again, where the graph meets or crosses the x-axis of the plane. So there are several ways to factor, and this includes grouping, quadratic formula, greatest common factor, or perfect squares, for example. And depending on what kind of equation you have, you can try all these methods, and there's also several more. So here's an example, and we have f of x equals x squared plus 8x plus 15. And so the method that I typically use is I write out s, p, and a number sign. And I look at the middle term, and I call this the sum, because the method I use, it comes out with a magic number. So we look at the middle term, we look at 8. So we're going to say that 8 is the sum of this equation. And so next, I take these two outer terms and I multiply them. And so you can't see it here, but there's a 1 here. So 1 times 15 is 15. So we're going to say that the product is 15. And then these two numbers, you're probably asking yourself, what could you possibly be doing with that? But if we look here, the sum, 8. The product is 15. What two same numbers are going to give me a sum of 8 and a product of 15? Well, if we write out the numbers that can make up 8, when we add them, 1 plus 7, 2 plus 6, you could go like that forever. And if we look at what numbers can make up 15 when multiplied, we get 115, 2 doesn't work, 3 times 5 works. And so I see this, and then I ask myself, well, 3 times 5 is 15. If I add 3 and 5, that also gives me 8. So I know this works. 3 and 5 are my magic numbers. So next I come over here and I write equals, and I rewrite the first term. But now instead of writing 8x, I'm going to split it into 5x and 3x. So we have 3x plus 5x. And even though I'm changing the equation, I'm not, because 3x plus 5x equals 8x. I write 15 here. 15. And so next, I go ahead and I group these together, and I group these together. I'm just going to find the greatest common factors between them. So x squared plus 3x, all I can take out is an x. And so I take that out and I rewrite the equation. And next, I look at the second one that I've grouped together, and what can I take out from here? A 5. So I write plus 5x plus 3. And now you notice that this x plus 3 and this one right here are the exact same. So that works. If these two things in parentheses, if these groupings did not say the same thing, then I know that this method is not working, and I have to come up here and I have to use quadratic formula or something else to find the right zeros. So now I bring these together, and this becomes one term here, and then I can rewrite x plus 3 because these are the same. I'm not adding anything to the equation. And so now I've properly factored this equation, but we're not done yet because we still don't have our zeros. So here I can go ahead and, for example, I'm setting each of these to 0, so I'm going to break it out. We have one over here and one over here. I say 0 equals x plus 5 and 0 equals x plus 3. Then all I have to do is basic algebra. So I subtract 5 and I subtract 5 from each side. And what am I left with? I'm left with x equals negative 5. And there's your first 0. And then you're left with minus 3, and I'm left with x equals negative 3. And so there you go. You just found both your zeros. And so these will describe where the graph crosses the x-axis. So if I'm properly writing these out, I have x-intercepts. I have negative 3, 0. I also have negative 5, 0. And those are my x-intercepts. So if I'm graphing, I can get a much better idea of which way my graph is going to go. And also later on, if I wanted to, I could find the maximums and the minimums, and I could also figure out more trends in the graph. Next, I'm going to just go ahead and write out the end behavior for this graph. And so I'm going to write as x approaches negative infinity, f of x approaches something, and then as x approaches positive infinity, the right hand side, f of x approaches something. So if we look back up here, in our very first term, it is positive, and that it is squared. So that means it's going to be a parabola, and it's going to be trending upwards. So I like to visualize and just draw something so I know what I'm doing here. So I'm saying the left-hand side of the graph, as x approaches negative infinity, f of x, or the range, is going to go to positive infinity. And then as x approaches positive infinity, f of x is going to approach positive infinity as well. And just for an example, if there is a negative sign here, I know that the whole graph is going to be flipped across the x-axis. So instead, it'd be trending downwards on both sides. So instead of writing positive here, I put negative for both of them. But thank you so much for watching my video. Hope you enjoyed and learned a little something. Bye-bye.